Welcome back to Practical PyTorch. In this video we train the CNN we built last time. The model does not change and the loop does not change, the exact 5 steps from playlist 1. We pointed at a harder dataset, CIFAR10, and run it for 20 epochs. A gap opens up as it trains. The model scores high on its training images but lower on held out ones. That gap is overfitting, and by the end you will read it from the curves. This is the training loop from playlist 1. Forward runs the batch through the model. Loss measures how wrong the output is. Zerograd clears the old gradients. Backward computes the new ones. And step nudges the weights. The return edge closes the ring, and the whole thing repeats for every batch. Not one line of this changes today. We only swap in a harder dataset, and around the middle of training, a gap opens up. Let's watch it happen. This video has 3 parts. First, the same loop on harder data, CIFAR10, normalized with its own mean and standard deviation. Second, we train for 20 epochs and watch 2 curves. The training loss falls, and the validation loss turns back up. Third, we name the gap between them, and the one normalization mistake to avoid. Which statistics may touch the validation set? First, the same loop, now on harder data. Forward runs the batch through the model. Loss scores how wrong it was. Zerograd clears the old gradients. Backward computes the new ones. Step updates the weights. Then back to the top for the next batch. The exact same training loop ring you already know. Nothing here is new. The training code is identical to that video. The only thing this one changes is the dataset and what the curves do. CIFAR10 is 60,000 small color photos. Each one is 32 by 32 with 3 color channels. Every photo belongs to one of 10 classes: plane, car, bird, cat, and 6 more. 50,000 of them are for training, and 10,000 are held out to judge the model. In playlist 1, the pictures were gray handwritten digits. These are color photos of real objects, and they are far harder to classify. Before training, we scale each color channel so its values are centered and evenly spread. We use the training set's own average and spread, 1 pair of numbers per channel. The 3 means are about 0.49, 0.48, and 0.45. The 3 standard deviations are about 0.25, 0.24, and 0.26. And that is the only preprocessing here to tensor and normalize. No augmentation yet. So it is 1 mean and 1 standard deviation per color channel. Red, green, and blue each get their own. This is the same normalize from the data loader lesson, now with 3 numbers instead of 1. The model is the small CNN we built in the last video, unchanged. 2 conv blocks, a flatten and 1 linear layer. 60,362 parameters, not 1 added. The recipe is plain too. The atom optimizer runs at a learning rate of 1e-3. Batches of 128, trained for 20 epochs. Everything is held fixed on purpose, so the only new thing in this video is the data. Now watch it train. This is the shape to expect. The training loss falls smoothly. The model keeps getting better on the images it trains on. The validation loss falls with it at first, then bottoms out and turns back up. The space that opens between the 2 curves is the overfitting. Notice there is no epoch number on this sketch. It is just the shape. The real numbers come next. These are the real curves from our run. The shape the sketch promised is exactly what happens. Both losses fall together through the early epochs. The training loss keeps sliding the whole way down. It falls from about 1.35 to about 0.33. But the validation loss bottoms out at epoch 6, marked with the dashed line. Then it climbs back up to about 1.1. From that point on, more training is making the model worse on held-out data, not better. The per epoch table says the same thing. At epoch 1, both losses are high. The training loss is about 1.35. The model gets about 53% of the training images right. By epoch 6, the validation loss reaches its lowest point, 0.83. That is the best epoch. Validation accuracy is about 72% and training accuracy is 76. After that they split. At epoch 12, the training loss is still dropping, but the validation loss has already started to climb. By epoch 20, the training loss is down to about 0.33. The validation loss has risen to about 1.1. The two have clearly separated. Now the gap and the one mistake. Now the same run in accuracy. By epoch 20, the model gets 88.57% of the training images right, but it gets only 71.13% of the held-out ones. That is a gap of about 17 points. The training accuracy keeps climbing because the model is memorizing its training images. The validation accuracy, the honest score, flattens out after epoch 6. That 17-point gap is what overfitting looks like in numbers. The model is fitting the training set, not the world. One more thing, and it is the mistake to avoid. The mean and standard deviation that normalize the data have to come from the training set only. You measure them once on the training split, then reuse those exact same numbers on the validation split. The wrong way is to compute fresh statistics on the validation set. That is a leak. The validation data has now shaped its own preprocessing, and its score is no longer honest. So the rule is simple. Only the training set's numbers may touch the validation split. Measure on train, reuse on validation, never the other way around. Let's review. Nothing about the loop changed, the same 5 steps from playlist 1. Only the data got harder. CIFAR10, normalized with its own per-channel mean and standard deviation. The training and validation loss fell together, then split apart. That gap between them is the overfitting. And that gap is now the thing to fix. Next, data augmentation narrows it. Your turn. From epoch 6 on, the training loss keeps falling, but the validation loss stops improving. So is the model still learning? Pause and think it through. Okay, here it is. It is still fitting the training set and nothing else. The training loss keeps falling because the model is memorizing those exact 50,000 images, but it no longer generalizes to held-out data. Past epoch 6, it is memorizing, not learning. That is why the model worth keeping is the epoch 6 checkpoint, not the one from the end. So the gap opened because the model memorized 50,000 fixed images. The fix is to stop it from memorizing, show it a training set it cannot memorize. Next time we add data augmentation, flips, crops, and small shifts. They make every epoch look a little different, so the model learns the pattern instead of the pixels. That is the next video. See you there.